All right, so in 7th grade today, we are going to be working on item number 16, and this item number is going to be on two-step equations with rational numbers. Now, you should have already written the objective and the vocab for this lesson. So you should leave some room up here if you haven't written the objective, and you should go back and you should write the objective. The objective should read something along the lines of, I can solve two-step equations with rational numbers, which means that it's going to contain both fractions and or decimals. Probably not multiple fractions and decimals within the same equation, but you're going to have multiple you're going to have both fractions and decimals. So let's look at a type of word problem first, because we're going to do these all by example. We're going to use the same steps we used for for two-step equations of real numbers to do rational numbers. Okay, so if we are going to go to the movies and we spent a total of $52, total should tell you that that's going to be some kind of equal sign, right? So I'm going to put an equal sign to remind myself that a total is going to be somewhat on one side of the equal side. The service fee for those tickets was a one-time service fee of $3.25. So that does not need to be multiplied. So I'm going to remind myself that's going to be some kind of constant that I'm going to add on to the equation. Okay, one ticket is going to cost $9.75. So that is going to be one ticket. So I'm going to need to multiply that price times however many tickets I'm going to get, because I want to know how many tickets did I get with my $52. Well, first of all, I know that we're going to use that as our variable, our x, right? Okay, so we know that our 52 is going to be on one side of the equal sign. Let's put it over here. And we know that we're going to have $9.75 per, right, per ticket. So that's going to tell us that we're going to multiply this. And we're going to multiply it by however many tickets we get, right? So if we did 10 tickets, it'd be like $97. So we need to know how many X tickets we purchased. And then we have to add the $3.25 service fee in order for us to be able to get how much the $52 would buy us. So now we're going to do the same steps as we will with integers, and we're going to say, well, there's a $3.25 that's hanging on there. So I'm going to need to subtract the $3.25 from both sides in order to get the variable more isolated. So we're going to subtract $3.25. And you wanted to make sure we would normally line that up a little better. We're going to get $48.75 on the left side or right side, and we have $9.75 times x on the left side. Now to isolate the variable, remember we're going to multiply or divide to isolate the variable. We're going to divide both sides by 9.75 to make the x by itself, 9.75. In that case, we're going to put the $48.75 inside the house, the $9.75 on the outside of the house. We'll move the decimal over 2 places. Okay, how many times does 975 go into 4,875? I can tell you the answer is 5. It's going to get 4,875, so that's nice and even. So that is going to leave us with x is equal to 5. So it cost we got 5 tickets for our $52 if we had a $3.25 service fee, considering that we purchased them online. So that would be how we would do something with decimals, right? We're going to follow the exact same steps. We're just going to have to make sure we're really careful to line up our decimal places. Okay, I'm going to write decimal over here because that's kind of what we did, right? We work with decimals. We also are going to need to work some with fractions, and I'm going to write that in the margin because here's how I'm going to deal with fractions. So I have about a half page of paper left, and we're going to look at this fractions one. We have 2/3 p minus 1/5 equal to 2/5. Well, the first thing I'm going to say is, there are fractions. if there are fractions, which is one of the first things we're going to ask ourselves, we're going to do this in two different ways, okay? So I'm going to split this up right here, and I am going to turn this into two problems. I'm going to have it this way, and then we're going to do it this way. So there are two different ways that we can approach this problem. The first way is just by saying, okay, so which one of these we need to get rid of the 1/5, right? So we're going to say that's subtracted. We're going to add 1/5 to both sides. That's going to give us 2/3 p, which is equal to 2 plus 1 is 3/5. And then I'm going to need to, this is multiplied, so I'm going to need to divide everything by 2/3, which means I'm going to copy dot flip, right? So p is going to equal to 3/5 times 3/2. Okay. And then when we carry that across, that's going to be 9/10, so p is equal to 9/10. But I have to tell you that I don't like dealing with fractions. And if I cannot deal with this amount of fractions, I can get rid of that fractions. I'd like to do that. So here's a tricky way that we can do this to get rid of those fractions. If we see fractions and we say, oh, is there fractions? And we say, yes, there's fractions. What we can do is we can multiply everything by the least common denominator. So we're going to go through and multiply everything by the least common denominator. In this case, we have 3's and 5's, and I know that 3 and 5 both go into 15. So I'm going to use 15 as my least common denominator. I'm going to multiply everything on the top and the bottom by 15. That's going to leave me with 15/1 times 2/3p minus 1/5 times 15/1 equals 2/5 times 15/1, because a 15 is the same as 15/1. Now we're going to go through and we're going to cross cancel. So I see that 15 and 3 in this first section here, I know that 3 goes into 15 5 times and 3 goes into itself 1 time. So this becomes a 1 and this here becomes a 5. When we look here, these are our 1s are already as far as they can go. The 5 and the 15, I know 5 goes into itself once, but 5 also goes into 15 3 times. And this last little bit here, the 2 and the 1, we can't do anything with, but I know that just like the last one, 5 goes into itself once and 5 goes into 15 3 times. I can go ahead and multiply those through. I have 5 times 2 is 10p minus 1 times 3, which is 3, which is equal to 2 times 3, which is 6. That makes it way easier. Now we just have a simple two-step equation. I can add 3 to both sides. It's going to give me 10p, which is equal to 9. I divided both of these by 10, and now I'm going to get p is equal to 9/10, which is the same as the other answer. So here are two different ways to get to the same answer. If you don't mind working with fractions, you might want to do this way. If you'd rather get rid of the fractions, you're going to multiply everything by the least common denominator. Now this is really going to work the best when we have lots of fractions inside the equation. If there was only one fraction, it might not work as well, but when you have multiple fractions in there, you're going to want to go ahead and multiply everything by the least common denominator to simplify it so that it's easier to solve if you don't like using fractions. I'm out of paper, so I'm going to need to go ahead and flip. If you want to pause the video, you can, otherwise follow along with me. So we're going to continue with item number 16. We're still talking about two-step equations with rational numbers. Okay, so let's look at some more. Here's a number 3 for you. What if we looked at 17 plus s, divided by 15 is equal to -4. Well, I can see that this is divided. This divides everything over here, right? Remember we talked about this yesterday. This is all touching that equation right there. So to get rid of that 15, to make it go away, we're going to multiply everything by 15 because those two are then going to cancel out. This one will be multiplied by 15. So that would leave us with 17 plus s, which is equal to negative 60 because it's 15 times negative 4. Now we have a nice single step equation. All we have left to do is subtract the 17 from both sides, and we subtracted because when we look to the left of the 17, there was no sign, which means it's positive. Okay, and that leaves us with s is equal to negative 77. Okay, so that is how we would deal with something that's larger like that when we didn't have any rational numbers. Let's do another one that won't have to do with fractions. Okay, because we all know that fractions are not really our favorite thing to deal with, right? So for this fourth one, we're going to say negative 1 is equal to 5 over 8b plus 3 over 8. Okay, so I see that we have fractions. Now we can do this in both ways just to make sure that we remember how this works. I'm going to solve it one with using those fractions, and the other I'm going to solve by getting rid of the least common denominator. So here I see I have a positive 3/8. Well, I would know that this would be, we're going to have to subtract 3/8 from both sides. And if I turn that 1 into 8/8, I would know that we'd add those together. This would be negative 1 and 3/8, which is equal to 5/8b. I'm going to turn this mixed number into an improper fraction. 8 times 1 is 8 plus 3 is 11. This becomes a negative 11 over 8, which is equal to 5/8b. I know that I need to divide everything by 5/8. So divide everything by 5/8 to move that 5/8 to isolate the variable. We're going to divide because it's attached to the b by multiplication. So this becomes a negative 11 over 8 divided by 5 over 8, which is equal to b. Remember, we're going to copy dot flip. So we're going to, or invert and multiply, copy the negative 11/8 times 8 over 5 equals b. We can cross cancel the 8s because they are both divisible by each other. And we get negative 11 over 5 is equal to b. So again, whoops, sorry about that. If you like fractions, do it this way. It's kind of complex, but you can do that. Or I can say I have a couple of fractions in this problem. They both have a common denominator of 8. But if I multiply everything by 8, I'm going to be able to get rid of all my fractions. So I'd have negative 1 times 8 over 1 equal to 5 over 8b times 8 over 1 plus 3 over 8 times 8 over 1. We multiplied everything by the least common denominator. These two cancel out and these two cancel out, and that would leave us with negative 8, because it's negative 1 times 8, which was negative 8, which is equal to 5b plus 3. So we've gotten rid of all those fractions. It's a lot easier to handle. We're going to move this, we're going to get rid of the 3 by subtracting 3 because we added 3, so we could subtract 3 from both sides. Two negatives or same signs add, right? So 8 plus 3 is 11. And same sign, keep the sign, so those are both negative. We're going to have a negative equal to 5b. We're going to multiply or divide to get rid of to isolate the variable. So we're going to divide both sides by 5. And that leaves us with a negative 11 over 5 equal to b, which if you look is the same answer. It just got a lot less complex when we went through and multiplied by the least common denominator. So with our decimals, we're basically just lining them up and making a good go of it and using the same steps we use for two-step equations with integers. And now what we're going to do with our fractions, if we see more than one fraction, we're going to multiply, or fractions that don't just have a 1 on the top in the numerator, we're going to multiply everything by the least common denominator to eliminate those fractions, and that's really going to help simplify the problem for us. So if you have more questions, you can log on to myhrw.com and you can look at more examples in the section for two-step equations with rational numbers, and the username is going to be Pounce with a capital P, and the password is going to be Panther with a capital P as well. So you can go on and you can look at those examples. The homework is uploaded into Canvas for you, And if you need more help with examples, you can go here to find those things. Okay, good luck on the homework. If you need help, you can ask or email.